Today we're going to explain Prim's algorithm. It's part of the graph theory, where we have a graph with vertices connected with edges, and we want to find the minimum spanning tree, the tree that connects all the vertices with the minimum weight. Prim's algorithm is very easy. I'm going to put the steps here, and I'm going to show you to solve the same exercise we solved in the Kurskal's algorithm video, so that you can see that we can create the same minimum spanning tree. Okay, so the first thing in Prim's algorithm is that we're going to create we're going to select a vertex, a random vertex. Okay, so select a random vertex. You can start with the vertex that you want. From there, you choose the edge with the smallest weight, and you keep choosing the edges with the smallest weight connected to my tree, which connect, and this is important, which connect vertices that haven't been added. With this phrase, we avoid the loops, because if we had a loop A, B, C, and I have already connected A and B and C, if there's a path in my tree to go back to A, I will not choose it, because A has already been added to my tree, and I don't want to select. In my algorithm, I don't select paths which connect vertices that have already been added to my tree. I only select vertices, edges that connect vertices that have not been added to my tree, and I keep on going until all vertices have been added. So I'm going to show you here with this exercise that as I said, we also solved in the Kurskal's algorithm. And we're going to start with A vertex. Okay, so we'll start with A. And the edge with the minimum weight is AB, so I'm going to select that one. Okay, so now I have from A paths with 5 and 5, and from B 1, 3, 3, 4, 7. So I'm going to choose the ones with the 3. Okay. No, I'm going to choose the one with the 1, sorry, which is the one with the minimum weight. And now I have 2 and 3s in my tree. I can add, connected to D I have 2 and 5, connected to A and have 5 and 5, connected to B I have 3 and 4, and 7 and 3. So I'm going to select the one with the 2. Okay. There's no sense now in choosing the path BE with the 3, because B is already connected to my tree, and this algorithm does not choose edges that have that connect vertices that have already been added. So that path it cannot be selected in the algorithm, and that way we avoid loops or closed circuits. So now we're going to see in my tree, I have another path with 3. Yeah, so this one in my tree, the next path with the lowest weight is this one. And now as you see, there's one with weight 1 here, which obviously is the smallest one. And as you see now, I have added all the vertices except C. So I have to add C, and I've got a path with D, with 10. I've got a path with 7, and I've got a path with 6. So I'm going to select the path with 6. So as you see, this is my minimum spanning tree. This is the same one that I obtained in Kurskal, and the weight is 6, and 4 is 10, and 2 is 12, and 3 is 15. The weight of the spanning tree would be 15. Okay. Let me do some more exercises for you so that you see. I have found a web, and I'll put it on the video. It's comes very handy because it produces exercises. So this one can create graphs, and I can choose the and I can follow the Prim's algorithm, and it will correct me if I'm wrong. Okay, so it tells me to start in A. In A, the edge with the smallest weight is 2. Now I can choose 7, 8, 4, and 6 in my tree, so I'll choose 4. Obviously, now I'm going to choose 1. And now I'm going to choose 3. And now I have to connect F and G, and I have 6, 8, and 5. I'm going to select 5, and then 6, and that's it. Let's do another one. Okay, so starting from A, the lowest one is 4, and then I have here 7, 8, 9, and 3, so obviously 3. Now 2 would be the one with the smallest one. Now I have to connect B, F, and G. I've got 7, 6, 6, 7. Okay, so I'm going to choose the ones with the 6. This I've already tried this web page, and it prefers if we start with an alphabetical order. So F and G. So I'll start with this one first. Yep. And now I have another. I have to connect G. I have 6 and 2 and 7. So I'm going to connect with the 2, and I have to now connect B, which is the one with the 7, and that's finished. Okay. Let's do another one. Okay, so A, the smallest one, is 2. Now another one of 2 here. Yeah. So now I have this one, which I suppose is 4, 6, 5, 8, 7. So supposedly the 4, and now I have the 1. And now the smallest one in my tree would be, I need to connect B and, so I have the 5 here and the 3. And that's it. Easy. And with this web page you can practice and you have to click on the edges and you can solve all the exercises. Now I'm going to show you how to solve some graphs with Prim's algorithm with a table, just in case the in your school or academy they teach you how to do it with a table, which is fairly straightforward.